Alright, Logic fans, welcome back to our second video, 1.4b, our second video on section 1.4, and let's just pick up right where we left off. So, conjunctions, just like disjunctions, have a left part and a right part, and just like just like disjunctions, we give them a really, really simple name. So the part to the left of the ampersand symbol, in this case what we're calling the P part, is known as the left conjunct. Okay, so if it's an or, then it's the left disjunct, right? And similarly, the right part is known as the right conjunct, and if it's a disjunction, it's known as the right disjunct. So here's an and, right? So the whole thing here to the left, the P part, that's the left conjunct of this conjunction, okay? And this part here is the right conjunct of this whole conjunction here in 3. Okay, so easy names, easy reference points. Okay, now let's continue our main theme for the day. So our main theme for the day, okay, is that the symbolic apparatus we already have is actually fairly expressive in the sense that it can capture a lot of the richness and nuances of ordinary language, and we saw that with we can capture both the inclusive and the exclusive sense of or. But we can do a lot more than that too. And in particular, there's one big thing we can do using only the symbolic apparatus we already have available, not introducing anything more, and that is counting. Okay, that's right. We can actually count using the symbolic apparatus we already have. So I'm going to show you how to do that, and this will really get your skills with negation, ampersand, and wedge going. So let's jump right in. Okay, so to illustrate to you how counting works using our symbolic apparatus thus far, let me just introduce to you an example. So the idea is let's suppose you walk into, I don't know, a friend's dorm room, and so maybe this is Mary and Sarah's dorm room, okay? And let's suppose that there's 3, I don't know, yoga balls. There's 3 balls in the dorm room. One of them's red, one of them's blue, and one of them's yellow. Okay, and you're sort of wondering how many different ways there are for Mary to own these balls. Okay, so one possible way is that she owns the red one, but she doesn't own the blue one, and she doesn't own the yellow one. So she owns only the red one. Another possibility is she owns only the yellow one. Another possibility is she owns none of them. Okay, so my first question for you is, and take your time with this, can you figure out how many different logically possible ways there are of Mary owning the 3 balls? Okay, how many different possible ways are there? So one of them is she owns this one and not these 2. Another way is she owns this one and not these 2. So that's 2 possibilities right there. But how many total possible ways are there? Pause now. Okay, so hopefully you've had a chance to think about it, okay? And it turns out there are 8 logically possible ways, and I've illustrated them this way. So this is R for the red ball, B for the blue ball, and Y for the yellow ball. These Y's here are yes and no's, okay? So don't confuse those. This is the yellow ball. So R is going to be our propositional constant for Mary owns the red ball, B for she owns the blue ball, and Y for she owns the yellow ball, okay? So let's go ahead and think about this for a second. In this way of owning the balls, she owns all 3 of them. She owns the red ball, yes. She owns the blue ball, yes. She owns the yellow ball, yes. Okay. In this particular case, she owns, in this way 2, she owns the red and the blue, but she does not own the yellow. Okay, and down here she does not own the red, she does not own the blue, but she does own the yellow. And so you'll see that there are 8 of these logical possibilities. Now, we can symbolize these sentences in a kind of interesting way. So for example, the first one, she owns the red ball, and she owns the blue ball, and she owns the yellow ball, okay, which we would symbolize this way, where this Y here is this one, okay? So it would be red and blue and yellow. Some more space here. So, for example, way 2, we would have she owns the red ball and she owns the blue ball, right? She owns the red, she owns the blue, and she does not own the yellow ball, okay? So, we're kind of ignoring parentheses here, and as I keep stressing, we will get into that in sections 1.6 and 1.7 and 1.8. So we're not going to be too concerned with them just yet here, but go ahead and see as an exercise if you can finish how you would symbolize saying, way 3, that she owns the red and not the blue, but she does own the yellow. How would you write that? And then similarly for the remaining 6 different ways she could own the balls here. Pause now. Okay, so hopefully you had a chance to do it, but yeah, your symbolizations would look like this. So, this one, way 8, says she doesn't own any of them, so it's not the case that she owns the red, and it's not the case that she owns the blue, and it's not the case that she owns the yellow. And that symbolizes that Mary owns none of the balls, right? So notice you're already kind of counting by doing things this way, but it can get even more sophisticated. So let's try an example here. So notice these concepts from section 1.2 are coming back in a big way. That's why I took the time to emphasize it then, but at least 2. So here's a sentence. Mary owns at least 2 of the balls. Okay? Now, we're going to try to translate this sentence and thereby establish that we can count using the symbolic apparatus that we have available. Okay? But in order to determine how to translate this sentence correctly using our symbolic apparatus, first let me ask you a question. This sentence, Mary owns at least 2 of the balls, which of these ways is that consistent with? So like if that's true, is way 1 possible? Yes or no? If this is true, is way 2 possible? Yes or no? Is way 3 possible? Yes or no? Is way 4 possible? Yes or no? And put all the ones that it's possible for, that it's consistent with here. Which ways is this statement consistent with? Pause now. All right, so notice the claim that Mary owns at least 2 of the balls is consistent with ways 1, 2, 3, and 5, but not any of the others. So it's consistent with way 1. So Mary owns at least 2 of the balls. Well, if this is true, right, if she owns the red and the blue and the yellow, then it's true that she owns at least 2 of the balls. So it's consistent with that statement. Okay, it's also consistent with way 2, where she owns the red and the blue, but not the yellow, right? But of course it would exclude something like way 7, where she only owns 1 of the balls, right? So if she owns at least 2, this can't be true. Okay, so here's what's interesting. We can look at this from the consistent with perspective. So I'll put the little, I'll put a C here for the consistent with perspective, and we can translate this by basically saying, okay, it's either the case that it's way 1, or it's way 2, or it's way 3, or it's way 5. So let's go ahead and do this out here. It's either way 1, or it's way 2, or it's way 3, okay, or it's way 5, and we don't need to tack on any others because those basically enumerate all the possibilities that could be if this is true, and it doesn't include any possibility that couldn't be the case, right? And so all we have to do now is substitute for way 1 this sentence, right? So either this is true, or way 2, right? This is true, or way 3. Was it way 3? Let me double check that. Yeah, it's way 3, or it's way 5, okay, which was this one, right? So that would be your full translation from the consistent with sort of perspective, okay? So from the consistent with perspective, Mary owns at least 2 of the balls is this, and this whole statement is the translation of Mary owns at least 2 of the balls, right? One of these has to be the case, right? And so, the parameter of the problem is that if you're way 1, you're not way 2, and if you're not way 3, and you're not way 4, and so on, right? You're one and only one of these, because notice it includes the case where you own none of them, okay? So the alternative way that we can do this is we can think about this from the inconsistent with perspective. So which of these ways is the statement Mary owns at least 2 of the balls inconsistent with? Another way of thinking about it is which of these ways cannot be the case, if Mary owns at least 2 of the balls. Pause now and see if you can figure that out. Okay, well, obviously, it's just going to be the ones that are not included here. So, if Mary owns at least 2 of the balls is true, then way 4 can't be the case because there she only owns 1 of them, right? Also, way 6 can't be the case because, again, there she only owns 1 of them. And, in way 8, she owns none of them. So it's got to exclude that case. It's inconsistent with it. So if we are going to translate this from the perspective of inconsistent with, so we'll do 1I, which is the inconsistent with translation of this sentence, okay? We're going to say it's not the case that way 4, and it's not the case that way 6, right? It can't be the case that way 4, and it can't be the case that way 6, and it can't be the case that way 7, and it cannot be the case that way 8, all right? So you could think about it just this way, and again, all you're going to end up doing is sort of plugging in here, right? So we're going to have this for way 4, we're going to have way 6 plugged in there, right? And it's going to be just like this. Let me do this and I'll clean it up for us in 1 second. Way 7 has to be included. And we also got to include way 8. So, okay. All right. So here it is all done out, and I'll bring this one all the way down so you can see it nice and clean. So it's not the case that way 4, okay, and it's not the case that way 6, and it's not the case that way 7, and it's not the case that way 8, right? So notice when you do consistent with, you're just or. So either it's this way, or it's this way, or it's this way, or it's this way. From the inconsistent with perspective is it's not the case that this, and it's not the case that this, and it's not the case that that, right? And you exhaust all of the possibilities. So it turns out that 1C and 1I here are actually logically equivalent expressions. Okay, and that's something we'll be able to prove once we get the notion of logical equivalence and some other techniques and methods available to us beginning in chapter 2. But yeah, so these are both perfectly fine translations of Mary owns at least 2 of the balls. Okay, and so what I'm going to do now is because we're running out of time, is I'm actually going to spill this into a third video where we continue proving to you that you can count using the symbolic apparatus we have available already, thereby hopefully demonstrating to you that we have the ability to capture an awful lot of ordinary language with our symbolic devices. See you on the next one.